Welcome to this demonstration of global risk analysis in Cosmic Frog. This global risk model features a retailer's supply chain with a network of production plants, assembly plants, and Tier 1 and 2 suppliers in Europe and Asia. In this demonstration, we will run 80+ network optimization scenarios that automatically calculate OptiRisk scores. We will also evaluate the impact of disruptions at key nodes in the network and develop risk mitigation strategies to make the supply chain more resilient. This apparel company has 3 different product families: accessories, apparel, and shoes. You can see the demand per product family and per subfamily for products like running shoes, shorts, backpacks, and tents. The map view shows demand at the end customer, which in this network are the DCs in Europe and the US. Our Los Angeles DC and Paris DC are 2 of our biggest customers with over 100,000 units of demand each. You can also visualize the baseline supply chain network on the map. Here we have our Tier 1 and Tier 2 suppliers in Europe and Asia. Tier 2 suppliers send their raw materials to the Tier 1s. The Tier 1s transform those raw materials into components, and then components are sent to the plants and assemblies for finished goods, packaging, and production. Finally, those packaged finished goods ship to the DCs throughout Europe and the US. And we have several different network and risk scenarios that we can test out. You can see a very diverse geographical distribution of this global supply chain. Next, we move upstream of demand to look at the packaging details. We have 3 different packaging plants, 2 in China and 1 in Italy. These packaging plants or assemblies take finished goods from the plants. We can see different packaging details about which location is packaging which product family, as well as an example bill of material for the backpack. Next, we move to production and see where our 8 different plants are located: 4 in Asia and 4 in Europe. This dashboard reveals details about which plants produce which product and which components. For example, we see Bacolod only produces finished goods, whereas Paris only produces components. There are 2 example bills of materials for backpacks and hiking shoes that show which components are needed to create that finished product. In this case, the backpack is made up of 4 different components: J, K, R, and V. We move back up the supply chain to our Tier 1s now, where we source our components from those Tier 1 suppliers. In this map view, we get visibility into the supplier breakdown, see which regions are supplying the majority of our components. Similarly, we move to the final location upstream into our Tier 2 suppliers. This is a very deep supply chain, but we get visibility into every echelon. Here you can see details about the Tier 2 suppliers, including location, quantity, and type of raw materials supplied. We can see that Eastern and Western Europe are the biggest suppliers of our Tier 2 raw materials. We just walked through the baseline introduction to the network, and now we can see the data that powers this analysis. Our Endura data schema is a unified data model that supports optimization, simulation, risk, and greenfield. This includes core supply chain elements like facilities, customer locations, suppliers, as well as business rules and policies. You can see the bills of material table for producing finished goods, packaging, and components. The next step in this risk analysis is to perform a stress test. What if each of the cities goes offline? What happens if a risk event occurs and shuts down a supplier, plant, or assembly? What is the impact to our profit and service? We created 80 scenarios to test out 80 different cities going offline. This is achievable due to the hyperscaling cloud infrastructure, which enables you to run hundreds to thousands of scenarios in parallel. You can see these 80+ scenarios running together in parallel here, and they all solve within about 30 seconds. Now we can assess the results of this stress test. One method to measure risk is to create a performance impact index. Performance impact on the city is equal to the baseline profit at that city minus the profit when that city is disrupted. If the city goes offline, the demand in that city cannot be fulfilled, and nothing can be produced in that city. In other words, nothing can flow in or out of that city when it is disrupted. In this example, Bacolod scores 100% and Istanbul scores 80%. These are the two highest impact cities. If they are disrupted, profit is affected the most. Next, we bring in the optologic risk score to add in a new dimension of risk analysis. We can assess both the internal and external risk factors. You can see the performance impact of Bacolod is 100%, and the geographic risk is high at a 7 out of 10. Next, we can assess the trade-off of spend, service, and risk, and see this comparison side by side. From a spend perspective, Bacolod is where we spend the most, the top right dot. For service, if Bacolod goes offline, we reduce demand fulfilled by 44%. And from a risk perspective, we know that Bacolod is the highest risk, with the top right dot showing that Bacolod is 100% highest risk scoring city. If your sites are high risk but low impact, then you may not need to change anything. If your sites are high risk but high impact, then you may want to de-risk them using a method such as dual sourcing to lessen the impact if that site is disrupted and goes offline. Further, we can look at the geographic risk summary of the overall network and see our various scores. This geographic risk summary is useful in summarizing the risks at each of our cities, whether it's distribution centers, suppliers, or plants. The geographic risk score includes components like economic risk, natural disaster risk, nuclear distance risk, political risk, epidemic risk, and distance to a biolab level 4. Another dimension in this analysis is to use sequential optimization. In this example, our priority number 1 is profit. We want to maximize the profit. The second priority, though, is risk. We want to minimize the geographic risk, subject to a tolerance of 5% profit, where we relax profit by 5% to achieve this minimum. In this result, a $2.2 million drop in profit from 46 to 43.8 improves the overall network risk by 1 point, from 5 to 4. We can see this decrease in risk from the 5 to the 4 from the left to the right-hand side. There's a lot less red on the right-hand side, so a lot less risk. And we can see a city like Shanghai moving from the red high risk down to the green lower risk. In conclusion, you just saw an end-to-end demonstration of how to incorporate risk into your Cosmic Frog models. For each supplier, facility, and customer, Cosmic Frog provides a set of risk scores. We evaluated the impact of city-level disruption across the network by running 80+ scenarios. In the future, we may consider utilizing multiple sites and implementing risk-sharing partnerships and performance tracking mechanisms.